Hi guys, this is a lecture for measurements and being able to take masses and volumes. So regarding the Aquaman video, you should have watched already. It was about 15 seconds long. Also played the theme music of Aquaman. Hope I don't get that video taken down for YouTube. That refers to something called parallax. A parallax, that's all one word. It's an effect where the position of an object can appear to be different if you view it from other positions. So as I moved my phone up and down, I was able to kind of make him stand on top of the rock that was in the aquarium. So keep this in mind because this is related to taking measurements, whether it is masses or volumes or temperatures, whatever it may be. So when you're looking at a graduated cylinder, which is this, when you're measuring volume, you have to look at the meniscus. This here, it kind of curves up like this, and notice how there's A, B, and C. The correct way to look at it is straight on because your measurement may be a little bit off depending on the angle at which you look at the meniscus or you look at the graduated cylinder or whatever it may be. So make sure you look at it straight on in order to get an accurate reading in terms of volume, temperature, whatever it may be. There are two types of menisci, I guess that's the right word. First one is concave and the other is convex. Concave, notice that from the way you're looking at it, if you look straight down on it, it kind of caves in a little bit. This is because of, this is an example with water, and convex, it kind of curves up like this. Mercury is able to do that. I hope you all remember why this is the case in terms of the concavity of the meniscus. So in a concave meniscus, the lowest part, that is where you're going to measure. If it's a convex one like this, you are going to measure here. So what is responsible for, at least in water, there are two properties, cohesion and adhesion. Cohesion means the water molecules stick together, and adhesion means the water molecules stick to something else. They adhere, kind of like an adhesive. So cohesion and adhesion is responsible for the concavity of water in a graduated cylinder. So it's best whenever you take volumes to measure to the last possible decimal place. You have to estimate it, if you will. So I guess you can kind of see in the PowerPoint. I guess that's kind of cheating. But if you notice, this is 6 and 8, say milliliters. So that means this must be 7. So you notice at the bottom of the meniscus right here, you're going to have to take your best measurement. So this will be 6.2, 6.4, 6.6, 6.8, and then 7.0. So if you look, this is 6.6, and you notice that the bottom of the meniscus is a little bit above it. So you got to give your best estimate, and we'll say 6.62. And you'll notice that the digits that you were absolutely sure of were the 6 and the 0.6, but the 2 is the one you had to give your best guess. So for this, students often ask, well, what if I just put whatever random number? Is that okay? For this one, I would probably accept 6.61, 6.63, and that's it. I wouldn't expect or accept something like 6.67 or 8 or anything like that because it's too, the curve is too low. Same thing, always measure to the last decimal place. So this is, notice how the scale changes. Each line is actually a ones place. So this is 36, 37, 38, 39, 40. So this is definitely above 36, but it's kind of right in the middle, so it'll be 36.5. And the 36 you were absolutely certain of, and that last one, the 0.5, is the one you had to give your best guess. 50, 60, 51, 52, 53, 54, 55. So definitely above 52, but not really quite 53 yet. So it's definitely not 52.2 or 1, so we would say 52.7. And the 0.7 is the last one, and that's the one you had to give your best guess for. So now we're going to look at taking masses. So your unit is most likely going to be in grams. So this is triple beam balance, okay? You're going to see this when you come into class on your appropriate day. But what you have to do is actually move these to be able to make sure that it's balanced on it. I promise it will make a lot more sense when you come in, but at least you should be able to read this. That's the general idea right now. So this says that this thing is definitely 265. And notice how this goes to 66. So 65, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Notice how the triangle point is actually kind of in between 0.7 and 0.8. So that means that you have to give your best guess when you do this. Notice how even when I marked it up a little bit, it's not really towards the far right. It's actually kind of towards the left. So you have to give your best guess, and we would say 265.72 grams. And that 2 is the one we are uncertain about, and that's the one I'm going to be lenient on, but you can't give me something that's too far off, okay? Again, make sure the beams are at 0. That's what you're going to do. You place your item on the scale, and you move these markers to indicate the actual weight or the mass. So with this one, it's 27.70. So look, 27, between 27 and 28. Notice, however, this is actually on the line exactly. That's where that 0 comes into play. So notice how if you moved it over somewhere here, like right about here, this one would be 28.4, say 4. So notice how you're able to give me that extra decimal. You got to do the same over here, like that. Again, this 0 is the one that you're quote-unquote uncertain about. Notice how with this 4, you're definitely uncertain about that because it's your best guess. So this is an electronic scale. Yes, it gives you all the numbers you need. However, this number right here, can always fluctuate even based on a gust of wind, can actually cause it to change. So that's the one that's going to be the quote-unquote uncertain one. So the first 3 numbers, we're good. We're certain about these. This is the one that we are uncertain about. For an electronic balance, what you need to do is actually, if you want to weigh a substance, a compound, what you would need to do is place a container on it first and hit the 0 or the tare button. You can watch a video on that. I'll give you a link in a bit. And what you can do is by pressing this 0 or this tare button right here, what it does, it allows you to take the mass or the weight of whatever you want to take, whatever substance you want. So, for example, you don't need to just put the substance on the scale. You can just subtract out the weight, if you will. But that's what this tare or 0 button does. You can watch that video. I'll give you the link in the Google Classroom. But now we're done. So I hope you learned something with this. Be sure that you're ready to go come class time, and we'll be able to discuss this and work on activity together. Thanks, guys.